Hello, my name is Pasi Talvitie. I'm a student in the master's program of Geoinformatics in Aalto University School of Engineering. And I am now presenting my master's thesis. The subject is detecting change in raised bogs using remote sensing. The supervisor of the work is Associate Professor Miina Rautiainen, and the advisors are Dr. Aleksi Räsänen and Dr. Niko Silvan, both from Natural Resources Institute, Finland. Collaborative partners include Natural Resources Institute Finland, Lauhanvuori Hämeenkangas UNESCO Global Geopark, and Metsähallitus National Parks Finland. The thesis concentrates on detecting change in raised bogs, especially the water level fluctuations in the surface of the raised bog. And this is done by using remote sensing materials, including aerial images and satellite images. The study sites are two raised bogs located in Western Finland, Häädetkeidas and Kauhaneva, which are both protected areas. Research questions are, is there or has there been any detectable long-term change in these raised bogs surfaces? And has there been any short-term change that is detectable? And does the change reflect climate change in the study area? The raised bogs are kind of wetlands that are pretty dependent on what's coming in from the sky. They get most of their water and nutrients from the rain. And in that sense, they have a very strong connections to the local climate. The materials used are aerial images from 1974 to 2017 by the National Land Survey and the Defence Forces of Finland. These images was taken approximately 10 years apart. This was complemented by PlanetScope satellite images from a single growing season in 2021, which was quite an average growing season in the terms of temperature and rain. Weather data from the area was also used. Now, the method used was to create an open water hollow model from the aerial images and satellite images. And this was made using a supervised classification method, traditional maximum likelihood classification. To overcome some of the defects of the classifier, object-based segmentation was used for the aerial images. And based on the models created, there was a difference was calculated between the studied years or the times of year. Now the results show a long-term decrease in Häädetkeidas, about 13.8% in the amount of open water hollows and 14.8% in area of open water hollows. In Kauhaneva, there was a 5.3% decrease in amount of open water hollows and 6.8% in area of open water hollows. Some seasonal fluctuation was detected from satellite images. And during the study period, the mean temperature in the area has risen over 1 Celsius degree. Now, the data and the methods are well suited to the problem. The salt and pepper effect of the classifier was effectively negated by using an object-based segmentation. And in the satellite images, the image pixel size itself, it was enough to negate this effect. The open water hollow models were validated using validation points, which were created using stratified random point creation. And based on this, F1 scores were calculated, the results averaging over 1.9, which is very good. Some noise was caused to the images by perspective and georeferencing errors, and some uncertainty to the result is caused by seasonality. But as a conclusion, a drying trend has been detected during the last 70 years. A short-term variation is also detected between spring and later summer, and a rise in the 10-year average temperature in the study area has been 1.4 Celsius degrees since 1955 to present day. Now, the probable mechanism of drying is probably the decrease of snow cover during winter time, which decreases the spring flood. And also in the summertime, the drought periods keep the water levels low. Now, the possible effects of this, the drying can increase forest cover and lead to warmer climate locally due to lower albedo of forest than open mire. Thank you for your attention. Kiitos.